Problem 3. A soccer team has 22 available players. A fixed set of 11 players starts the game. Let's draw that out. 22 total players and 11 start the game. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the other 11 are available as substitutes. Okay? During the game, the coach may make as many as, be careful to read that, as many as, so up to 3 substitutions, where any one of the 11 players in the game is replaced by one of the substitutes. For example, this person can sub in for this person. And then, of course, they would become out of the game. No player removed from the game may re-enter the game, so this person who just got substituted can no longer enter into the game, although a substitute entering the game may be replaced later. No 2 substitutions can happen at the same time. The players involved and the order of substitutions matter. Let n be the number of ways the coach can make substitutions during the game, including the possibility of making no substitutions. Find the remainder when n is divided by 1,000. Seems like a pretty standard casework problem at first, right? Given that you can make 0, 1, 2, or 3 substitutions. So this should be a decent case for casework, right? In the case that the coach makes 0 substitutions, there's only one way to do that. In particular, do nothing. If you're making 1 substitution, let's think about that. Well, we can pick any of the subs to sub in, but we also have to pick one of the people already in the match to be substituted out. So it follows that there are 11 ways to pick the sub, 11 ways to pick the person in the game. That's not interchangeable, right? Every pair of choices yields one different way to substitute someone out for someone else. So that gives us 121 for the 1 sub case. Suppose now we have 2 substitutions. Well, then let's say there's 11 times 11 ways to make the first substitution. So now this guy is in the game. And then since someone who's been substituted out cannot rejoin, we're just going to put them to the side here, right? So they're no longer available for this team. Now, how many possible ways are there to pick a new substitute, right? Well, there's 10 remaining substitutes. And notice that out of the people in the game, well, there's still 11 people in the game, all of which are available as substitutes, right? No matter what we chose before, there's still 11 people in the game to substitute. So now that we've done that, say we picked the same person who just got substituted to substitute out for this person over here. So now this person substitutes in, and now we have 2 people sitting out, but we still, remember, have 11 people, right? So there are only 9 possible subs and 11 people still in the game who can all be subbed out. In this case, for the 2, that just ends here, and we get, some number. In this case, it should be 13310, because it's 11 cubed times 10. Finally, if you make 3 substitutions, we do the same things as before. 11 ways to pick the first person subbed out, times 11 ways to pick the person in the game to be subbed out, times 10 ways for the next sub, times 11 ways for them to replace someone. And then finally, since there are 9 subs remaining, all of which are available, there are 9 ways to pick the third sub, whereas there are still 11 people in the game that all of whom can be subbed out with no restrictions. So that gives us another number, and since our answer is just the sum of these, remember because this number is way too big, we're just looking at the number when n is divided by 1,000. So let's be smart about this and not calculate this entire number. Let's just think about, well, we already have a 10, and 9 times 11 is 99. So this becomes 990, which is just negative 10, notice. So this is equivalent to like negative 10 times 11 times 11 times 11. Oh, that's just 13310 again, but it's negative this time. So actually, these added up should become 0 model 1000. So we just end up with 1 plus 121 for a final answer of 122.